continuous integration and continuous delivery. Okay. Right. First, I will be using the UCSC node halfway. Then I will be using our own nodes as well. Two nodes, one node for Jenkins, which I have not shared you yet, but I have shared you the uh, JIT node. I think actually that is the same node that we used in semester 2 web development. Okay, exactly the same node. So if you attended semester 2, the same node you must be having. Right, continuous integration and continuous delivery. So when we develop software, especially in agile approach, so the idea is continuously deliver the product or continuously integrate our code to the main build. Just give me 1 minute. Right, sorry for that. So continuously integrate our code to the main build. Don't keep your code with you too long. Of course, don't check in your unstable code, but don't unnecessarily keep your code. So as soon as you are confident that your code is working fine, integrate it to the build or the repository. And from the repository, we want to frequently integrate it into the releases or production. So continuous integration is you developers integrate their code into the build. Continuous delivery means we frequently give releases, which includes our continuously integrated code. So the result is customers get frequent releases. That means they get early competitive advantage, we get early feedback. Okay, and also the workload is gradually getting finished because otherwise we keep code for too many time, too many long. Remember, one of the agile concept is don't keep too many tasks open. Start just one or two tasks and finish it. Fully finish it. Integrate it to the build, integrate it to the delivery, and then concentrate on your next task. Right. So continuous integration, continuous delivery. Okay. And also we will look at version controlling system called JIT and build system called Jenkins. Okay. Build system called Jenkins. Right. So therefore you will be learning JIT as well as Jenkins. So JIT is to continuous integration. Jenkins is helping you to continuous delivery and also it helps continuous integration as well. Right. So therefore, it's very important that you understand the difference between CI and CD. So continuous integration is a method of continuously verifying the condition of a code base through automated testing. You continuously build it and also run the test cases. Remember last time we discussed about Java unit test case framework? So that unit test running also we can integrate into build. So after the build is done, if there are compile errors, the build will fail. If there are no compile errors, then we run the init test in the build. So that is not the developer is doing. That is something the build does. Maybe we can run the build once a day. Okay. So then entire day's code is rebuild. Again, the test cases are run. Okay. And so maybe once a week we are giving delivery. So continuous integration means whenever your code is stable, you integrate into the build. You don't keep it with your local machine. Continuous delivery means you frequently give releases to the customer. Frequently, maybe once a 3 weeks, once a 2 week, not once a month or once in 6 months. That is the whole purpose of agile development. Okay. So the goal ultimately when you do CI and continuous integration and continuous delivery, make our software development and releases process fast and more robust. And in order to do this CI and CD, we need a lot of tools so that developers can do it faster. Developers can do it with minimum effort. Otherwise, developer will spend a lot of time building, integrating, and so on rather than developing the software. Right. So again, CI code get pushed to the version control system. So we frequently push code to the version control system rather than keeping it in our local machine for long period. So that others can see the changes and they can start working on top of your changes. Sometimes they will depend on your work. And the build server checks the code as soon as it is pushed. So whenever we push the code, the build server can check whether it's are there any errors, is it going to fail any test cases. Okay. So when we say as soon as possible, it may not be immediately, maybe once every 3 hours, twice a day, the main build will be running. And developers receive the feedback, whether the build is passed or fail. Maybe twice a day you get that mail, or maybe once a day, and which test cases have passed, which test cases have failed. So then if a particular test case is failed, and if you know that it's maybe because of my change, so you need to address it. If the build fails, you need to address it because the error will tell which class, which method results in compile errors. So then the relevant person must immediately attend to that and fix it. And of course, continuous delivery means the reliable releases we give it to the customer frequently, reliable releases, right? Fully tested, fully stable releases, and frequent deployment to the production servers. And as much as possible, automate these things. So therefore, first thing is CI, that is developers push code to the repository. Then CD, that is your build, tested, deployable software is frequently released to the customer. CI, continuous integration, continuous delivery. Right. So now let's look at features of good continuous integration and not continuous delivery. This is more between developer and the repository. So good continuous integration process or supported tools will decouple stages. Like the code is only with you now. Now your code is added but not yet committed. Now your code is committed to the repository. Likewise, different well-defined stages your file going, your different source code files going through. And therefore, it's very easy to undo something if something not going well. You select certain things and put it into the repository and so on. Right. So well-defined stages, which are sort of a decoupled stages. Then repeatable. So that means we want to make it automated. Right? Sometimes it automatically happens once a day, twice a day, so that developers need not pay a lot of attention to that because developers' main task should be designing and development. And this is an interesting one: fail fast. Right? If you have made a mistake or anyone, anyway, it's going to fail. Maybe fail the build, fail the test cases, fail the functionalities, but it's better to fail it fast rather than late. Because when you're fresh with your code, and of course, your task is make sure you do it proper way, and test it before put it into the repository. But so say today morning you did a change and you check in, assuming that there's no error. but maybe in the noon, there's a build, right? You have already checked in your code. Now, maybe in the noon, the build will fail. Maybe because of your change. Of course, you are not supposed to check in that kind of code, but we all humans, we make mistakes. It's better to detect it early because you are fresh. You know what you did rather than you check in code today morning and the error is after 2 days. So then maybe you are now concentrating on some other thing, right? Things are real mess. So therefore, we all can make mistakes. Therefore, it's better to detect it early. So how to detect it early? Frequent builds. Frequently we check in and frequently those changes are built. Okay. Right. So that is CI. Features of continuous delivery. So this is delivering to the customer or deploy to the production service. So we need to make sure that it suit our requirements, our environment. Is it a Java based application, PHP application? Is it Node.js application? Right. So it must compatible with the environments. Are we using MySQL, Oracle? So, so good continuous delivery frameworks support these technologies. Or we should be able to pick and choose the continuous delivery tool stack that is suitable for our application. And pipelining means, so when we do the delivery, there are let's set of tasks we need to do. Maybe run some integration testing, right? Prepare your artifact for the deployment, deploy it to the servers, maybe again do some testing. So then get the verification by QA people and then deploy it to the production server. So there can be a lot of tasks. And depending on the results, there can be alternative paths, if else conditions. So we good continuous delivery tools support managing these workflows, automating these workflows. So that is what is meant by pipelining. So pipelining is managing your workflows towards the deployment of the product. Okay. So that your system engineers or build engineers, cloud engineers task is less. So their workload is partially absorbed by these continuous delivery tools. Okay. So that is called pipelining. So there are questions on pipelining in your past papers. Right. And also global unique versions. So these days, when we develop software, sometimes our team members are in different countries. So some team members are in UK, some team members are in Sri Lanka. So good build tools must have the facilities to for the developers to check in their code from anywhere, and also the tool must be able to build it and deploy it to different servers all over the world in the cloud. So they must be able to deploy it to different clouds, maybe Amazon cloud, Google cloud. Okay. Maybe the same product you need to deploy it to multiple servers. So good continuous delivery tools must support those. So these are serious stuff. So that is why now we have separate set of engineers called system engineers, cloud engineers. So they don't directly involved in software development. So their main task is doing these things: continuous integration, continuous delivery, and partially customer support. Okay. So if you go to topjobs.lk, there are almost every day there are job vacancies looking for system engineers, build engineers, cloud engineers. So this is your subject there. So who should know about continuous integration and continuous delivery? Of course, developers, because developers also need to check in their code to the repositories, and they should know what happens next. Then QA engineers, because this process include heavy testing, some manual testing, some automated testing. So QA engineers must know what reports are generated. So which type of testing you can integrate it to the build, especially the unit testing. And obviously system administrators and system engineers, because they are the one who mainly involved in delivering the product, deploying the product to the customer production servers. It's a lot of responsibilities because you are taking it live. Maybe it's a very critical system, maybe a banking application, maybe application for share market in a particular country, forex market, supermarket chain. So these things must be very reliable, and those who know the subject must handle these. Those who know the subject, who know the consequences, those who know how to come up with solutions if there are issues. Okay. Right. So there are plenty of CI and CD tools. It depends on different technology stacks and different requirements. But we are going to look at only one technology from CI, that is JIT, and one technology from CD, that is Jenkins. Okay. Right. What we are going to do first is not Jenkins, rather JIT, because we are going to start. I do any natural ways also like that. First, you need to learn about continuous integration. Then you need to learn about continuous delivery. So I don't know, for some reason in your note it is first continuous delivery, then continuous integration. Okay, so therefore let's first look at continuous integrations related thing. So that is the second half of your note. Right. Introduction to version control system. By the way, we have completely done this topic, entire thing in web development subject. So I'm using the same note, right? So the tool we use under version controlling, that is continuous integration, is JIT, not GitHub, the free and open source version JIT, command line version. Right. So what is a version controlling system? So when you develop software, whether it's a web application, mobile application, standalone application, your software consists of thousands of code, classes, configuration files, right? UI related, application develop, process related, business logic related, database related scripts. So hundreds and thousands of code, and your team may be somewhere around maybe 10 developers, 20 developers, 10 developers, 3 QA engineers, 1 project manager. So it's a teamwork. But all of you guys are working for a one product. So then obviously the challenge is how to manage this code base, because the code that you change today morning, maybe someone want to do some modification in the afternoon. Maybe in the morning itself that guy is looking for that code, because both your tasks are related to same code. In software development, there's nothing called this is my code, this is your code. You are not supposed to change my code. No, there's nothing like that. It's our product. Anyone can do changes, because when it comes to a functionality, uh, you may need to do changes at functionalities in all over your product code. That is why we need discipline software engineers. That is why we need everyone follow standards, so that when you do some changes to the code, I must be comfortable reading your code and understand. When I do some change, all the other team members must be comfortable understanding my change, because they may need to do some changes on top of my code. Okay. right? So therefore, we need version controlling system so that when I do my changes, I should be able to check into the code repository so that others can get it. And also it will prevent conflicts because if two guys do the changes on the same class or maybe the same methods, if someone check in first and the other guy will override it, override means the previous guy's change is lost. So this version controlling system detect those things and merge your changes and my changes, both will be there. And if it cannot be merged automatically, it will give warnings, error messages, and ask developers to manually merge it. And also we can see the version history of each and every file. We can change, we can see the difference between version 1 and version 2. And there are comments when someone check in a file so that we can get idea about why that particular developer did that change. And we can create branches. We can create tags in version controlling systems. Right? Different branches for different customers because different customers might need slightly different functionalities. So many features. So therefore, this is very important aspect. So that is why Microsoft consider their GitHub because they bought it for very huge amount of money. They spend a lot of money to get that tool, GitHub. Right. But we are using the free and open source version JIT. Of course, JIT is not the only tool. There are some other tools, but JIT is the most popular right now as a version controlling system for continuous integration. Okay. So we call them version control system. So we can use it as a backup also because not only in your machines, your version control system has your code. Not only the code, it has the previous versions also. Maybe 3 months ago version, 2 months ago version, yesterday's version. And it keep track of different versions of each and every file and which version is related to which release and so on. And it maintain change history because whenever you check in support, you are supposed to give a comment. What was the reason? What was the change you did? Which can be really helpful when you are troubleshooting some issues. Because the developer may not be there after maybe 2 months, but the project might continue, right? So, but your comments will be there, though you are not there. And obviously allow multiple developers and sometimes they are from different locations to collaboratively work on same product. And we can merge changes. So when there are two people do the changes to the same file at the same time, still you can merge it using these tools. And always it is gives accountability. Who did what? Because you can see who has do which modification of that file. We can compare two versions and see exactly which change that particular user did. And we can create tags like release 1, release 2, release 3 tags. So at any time you can revert to a previous release. So you get that code tagging. We can create branches for different customers, different language supports, different customizations. So that means your same product, but this is your main branch, but there are sub branches also of that product. So similar functionalities are there, but at the same time, these branches will have special functionalities. And for example, when you do a big bug fix to the main branch, you can merge it to the other branches because they also need that fix. So likewise, there are a lot of features. So you fix the bug in the main branch and merge it to the other customer branches because customers also need that fix. So that is called merging, right? Tagging, branching, merging. So these are the words. So you need to understand these words. Right? So spend some quality time to understand what is tagging, what is branching, what is merging, what is check in, check out. If you don't understand, if you ask, I can again explain, okay? Because I have been using these tools for last 10, 20 years. In the industry, I have used it 10 years, different tools. Right. So there are two type of version controlling systems. Centralized version controlling systems and distributed version controlling systems. Okay. So centralized version controlling systems have less features. So very rarely now we use, but in about 5, 10 years ago, we use these centralized VCSs. So there we have only one central repository, right? One code base, but multiple people can check in, check out, and those things merging, but only one code base, one branch, right? One branch, just the main. Okay. So therefore, it's very difficult when you have multiple customers, multiple versions for different OSs and so on. So when it comes distribution version controlling systems, so we have all these features, branching, tagging, merging, right? All these additional features that we required are there so that we can handle multiple version of the same software, customization for different customers, okay, and so on. So JIT is a distributed VCS. So that is why JIT is very popular. Okay. Right. So when it comes to JIT or any version controlling system, so these are the words we use. Repository. Repository is the location or the storage where we check in our code. All the team members check in our code. So ultimately, your big code base is your repository. Your repository. So then the server. Server is where your version controlling system is installed because so there are different developers, right? You don't keep the build, right? Your individual machines, you keep it in a server and you all check in code to that and you check out code from that. When you need the latest code, you take it from the server for the repository. And when you done your changes, you check into the server or check into the version control system. So this must be in a different independent machine, not one of the developers' machine, because this must be available 24 hours, 365 for your developers. And also from this repository, the build system will take the code and deploy and deliver to the customer. So there's a second part also. So still we are in the continuous integration. So then there's a continuous delivery. So that continuous delivery will take code from this repository, this version control system. Okay. And so therefore this is your server, VCS server. And all the developers' machines are clients. Clients. And developers have working copy. Working copy means you take it from the repository, but now you have some modified code also. Your working copy is different from my working copy. But at the end of the day, or when the code is stable, you are supposed to check in your changes. I'm supposed to check in my changes so that your working copy is synchronized with the repository. Right? So you have the main. So then you can have different branches of the code base for different customizations and so on. So you must first familiar with these words. Actually, you can't familiar with the words first. While you are learning, you must gradually familiar with these words. At first, it can be very sort of a challenging, but once you get used to it, so these are not difficult things, right? So the real challenging things are designing software, developing software, not this. These are easy things. But initially, yes. Initially, because when things are new to you. So usually these build engineers work is easier. The real challenge is software engineers work because they are the one who come up with solutions to problems. So these are just repetitive things, right? Managing the build, and so once you set up it, you are very comfortable with that. Right. So when you have your version controlling system like JIT, so these are the tasks that you will be performing. You add your code, check in, check out, and different systems use different terminology also. Right. Input one tool, maybe you use one word. Another tool, they use for the same task, they use a different name. But so you must know that, okay, so though we use two different names, these are the same tasks. Right. So add to the repository, check in, check out, ignore. Okay. Ignore means you allow file to exist in your working copy, but not in the repo. So you don't take it, put it into the repository, but it's your local copy. So you're not planning to put it into the repository also. Maybe it's a local configuration file for your IntelliJ, right? Your own server, local server. So it's your local task. Then revert means undo. So you check in something, but you found some issues. Now you want to undo it, right? Update or synchronize, right? Do a difference or see what are the changes between two versions. The concept of branch, concept of merge, concept of conflict. Okay, right. So we'll gradually look at those things. Okay, right. So then, what is mean by locking a file? So you can lock a file so that others are not supposed to get that file, or they can get it as a read only, but they are not supposed to do changes and check in until you release the lock. That means you are doing some big changes to this file. So when you lock it exclusively, others are not supposed to do changes to that file until you check it. But there are shared locking also. Then you also can take the lock. Other one also can take the lock. But they know that there's a possibility of conflicting. Sometimes maybe you do changes to the first method X, other guy do changes to the method Y, then you can safely check in without any conflict. But it gives you idea that there's a possible conflict when it is locked. Okay. Right. So these are all version controlling systems. Right. CVS, SVN, GT is the one that is most popular right now. Right. So these are more specific, but these three are the most popular. CVS, SVN, JIT. Before JIT, these two were the most popular, but now it is a JIT. Right. Now we move to JIT. So JIT is distributed version controlling system. Actually, the word should be version control system, not revision control system. And it support non-linear development, that is branching, tagging, and it support almost all the OSs. That you can install it in any machine, any client, any OS can be a client machine. Maybe you are using Mac OS, maybe you are using Linux. You can interact with the server. Right. So when you're working with JIT repository, I will explain how to install later. So there are different stages. You call it your working directory, staging area, and the JIT repository. Okay. So in your working directory, when you do some changes, so now you say you are in a staging area. Stage, that means you have done changes. Of course, first you take it from the repository, but right, then you have done some changes, which you have not yet check in or commit. So then you say that you are in the staging area, that particular file, so set of files. So then you commit it. When you commit it, only your changes are going to the central repository. Now others, when they check out, your changes are also available to them. Okay. So this word is little bit confusing. Staging area means you have done some changes, but not yet committed to the repository. Right. So then you must know how to install JIT. So this is how you install it in Linux. So remember, you need to remember these commands because maybe you are using in Windows, but examiners have asked how to install JIT in Linux. Right. So this is if it is Fedora Linux. This is if it is Debian Linux like Ubuntu. So, so especially remember this one because you are supposed to familiar with Ubuntu, right? Sudo apt install git all. So this is normal thing, right? Sudo, that is you are taking the sudo privilege. This is the normal way we use apt install git all packages. Okay. But if you are using any other operating system, you need to separate the install it, download, install. Right? Windows, you can just download and install the exe file, setup file. Okay. Right. So if you are interested in, of course, you must install. If you haven't done it already, go to the Git site, download and install, just like any other software installation. Okay. Right. From this point onwards, I will use our note, right, to explain how to practically work with Git repository. Right. Check in, check out, creating a branch, tagging, right? So that we will do after the break. Anyway, that note is available in Google Classroom. I gave you a screenshot also under continuous integration. So this is what we are going to use, this note. Okay. Right. So now it is 7:04. Now practical part we can do very fast, right? It won't take more than half an hour. So then we'll start doing Jenkins as well. So now we move on to our first tool, which is continuous integration tool, that is Git. Okay. So Git is a distributed version control system that we can use to manage source code. Okay. So with Git, you can check in or commit your files to see the version history, tagging, branching, merging from one branch to the other. Those things can be done. So if you want to install, of course, you are supposed to install it. Get it from gitscm.com. Okay. And install it, right? It's a executable file or the installation file. So that is if you are installing it in Ubuntu. Okay, so that you should be able to do it by yourself. Once you install it, take a command from 10 type git minus minus version. If you get the version, that means your git is properly installed. Okay, right. So you can create a small folder somewhere, right, anywhere. Say I have codes. Uh, bit 676. I have created a folder called JIT. Okay, so let me delete this. So this is I have just created a folder. Uh, this is my working folder for my source code. Okay, right. So now I can take a command line. Of course, I have already installed it. Okay, but that I'm not going to explain because it's simple installation. Take a command line and I created my folder in D drive. Therefore, I'll go to the D. Then I'll cd into that folder. Assume this is where your Java or whatever source code is, okay? Right now I'm in that particular folder. Right now, if you want to check whether your JIT is properly installed, just type JIT minus minus version. I may not be having the latest, right? Maybe slightly old version because I installed this maybe about 1 year back, right? So your version might be uh, later than this. That is fine. So if you get this kind of a response, right? So that means your installation is properly done. You don't need to do any other configurations. Right. So then you can use command line or PowerShell. Any both are the same. Okay. Right. So then you need to configure. That means if you have first time install it or this is first time you are configuring your repository, you need to do some configuration. So this is how you do it. You need to create your user and maybe you can set up your email address also because if you are going to integrate it with the build system and build system generate emails and so on, right? But for us, we just create a user. So let me copy it again. So git config. So this should be double quotes, right? You can create a particular user for this particular session, or it can be permanent user as well. And git config minus minus global user dot name your username. Okay. So different users, because when you check in something, you need your username will be used so that you can see what your changes you do and others can see what changes you do because every time you do some check-in and so on, your username is also recorded. Okay. Right. So now I have created, maybe already I have created this, but I just demonstrate it. Okay. Right. So then if you want to double check whether that user session is now created, you can just type git config user.name. Right, it confirms that my current session is for this command line. It is Nalaka. It can be any name you want. Okay. Right. Right. Now you can initialize your repository. So because you can have multiple repositories in different folders. So this still I have not added any code or something here. Right. So how to do it? There's a command called git init. So all these things they examine in your exams also they have asked. Okay. Git init. INIT. So it says initialize empty Git repository. Now, if you go to your folder, you can see it has added a folder called .git. So it will have some configurations. Okay, some configuration files. Don't worry about those things. So those are internally used by your Git. Okay, so that means now this folder is a Git repository of Git repository or your local copy of the Git repository. Okay. Right. So let me use the PDF file because it's easier for me to use the PDF file rather than going for this here and there. Okay. I have already shared you this note in the Google Classroom. I can easily copy paste from this. Okay. Right. Now I have initialized my Git repository local copy. Now you can create a file. Right. Of course, you can create a. So this is if you are using PowerShell, right? You don't need this to create your file. Just create a file normally. So let's call it. It can be Java file, PHP file, it doesn't matter, okay? New, say text document. Say I'll call this hello.java file. Okay, hello.java file. Maybe I will add some code class hello. Right, of course, you need to add your code and so on. Okay, fine. So I have added a code. Now you can check your status. At any time, you can check your Git status. That means which files are not yet added, which files are sync, and so on. Okay, so that is called checking the status. It's very easy. You just type Git status. You need to remember all these commands. At any time, you can type Git space status. Git status. And it says, okay, there's a Java file, there's a file called hello.java, which is not yet committed, right? Which is not yet committed. That is, it's your local file. It is untracked file. That means your repository has no idea about that file. It's only your local file. Okay. That is called untracked files. Usually it's shown in red. Okay. Now, now you can add it to the repository. So then it is added to the repository, but still now then we call it is in the staging area, staging level. But just because you add it to the Git repository doesn't mean that you have committed. Right? So how to add it to the repository or put it into the staging? So there's a command called git add and your file name. Okay. So say git add git add and my file name is hello.java. Hello.java. Make sure you type it correctly. Now, if you type git status, now you can see earlier it was red. Earlier it was untracked file. Now it is tracked, or now it is in the staging area. Okay. You can say if you want to unstage, you can unstage using this command git rm. Okay. But now it is stage. Green means it is in the stage level. Still not committed to the repository. Right? But earlier it was untracked. Now it is track or stage file. After doing git add, git add your file, okay, or multiple files, so you can use star all the files and so on. Right. So now next task is, of course, usually when you add it, you want to commit it also because this is not yet committed to your repository so that others can get your file. Right. So how to do that? You just say git commit and minus m your commit message. Right? Whenever you add something to the repository, you need to give a comment. This is the reason, right? And then the file name. If the file name is not there, that means all the staging files you need to commit as a whole. And git commit minus m. Now in the staging level, now we are going to commit. Git commit minus m, that is message. I'll call initial file. If you have spaces, make sure you use quotes. Initial file, then the file name. Of course, file name is hello.java because I just want to add only this because I have only this. Right. Okay. There's a typing mistake, so it must not be fit, it must be JIT. That is why I got error. Right. JIT commit. Right. Now it says it has been added to the master. Master is the major branch or major. Okay. It's not a branch, that is a major repository. Okay. Now if you type again git status, now it says nothing to commit. So because no file in your local level, that is red, no red thing. no green thing, that means nothing is in the staging level. That means you have added but not committed, right? So now it's your files are 100% synced with the repository. Now, if you do a change, now after you commit, assume you do a change to the file. Okay, say let's add something. So some comments, save. Make sure you save it. Now, if you type git status, now again it says you have things to commit. Okay, things to commit. So so that means those are not sync. Those are not sync because you did some changes after commit. Now again you need to add, right? After modification also you use the word add. So that means now it is in the stage level green. Now you can again commit. Okay. Of course, you can give a different message because this is your not the initial file. Right? Add say basic functionalities. Now if you type, okay, now again I type fit. Let me change it. It should be git. Now again everything is sync. Now again if I type git status, right, everything is sync. Okay, so that is how you do it. Even after doing changes, you need to add and commit. Okay, add and commit. Because often we need to do both add and commit. If you want, you can do both as well. Okay, that means you first add it, then you use ampersand to ampersand, then you commit. Because anyway, after adding, most of the time you commit. So this is in a single line. You do add and commit. That means you don't just stay in the staging area level. Straight away you check it. Okay, commit. Right. At any time, you can see the log, your activities. So git log. So all your activities you can see. Right. So these are the activities I did from this particular thing. You can see. So my comments are there. Okay, you can see add basic functionality, initial file. Okay. So this is my first activity. This is my second activity. And timestamp, everything is there. Okay. Everything is there. So you can see the email address because I already had set my email address. I didn't set it again because I already have set. I actually this username is I created some time back. Okay. And so that is how you check the log, your activities. And if you want, you can ignore certain files because otherwise, when you type git status, it will say that there are untracked files. But sometimes, yes, untracked. Maybe those are your local files related to your IntelliJ, your Eclipse ID, and so on, right? So then you need to say that, okay, don't track these files. Right? So it's very easy. You create a file name .gitignore in your root folder. In your root folder, okay? New file, just say text file, but make sure it's .gitignore, okay? So the extension is gitignore, no name. So then you can add patterns of files where you don't want to track, or your JIT must ignore those. Okay, for example, let's say all the exe files, so all the text files you want to ignore, all the text files. Okay, maybe you are only interested in Java files, XML files, and so on, right? Let me open this. So then you add entry like this. You can have multiple entries. Okay, so let's say txt files. Now, if you add a txt file to your folders, say new text file, say readme.txt. Now, usually when you say git status, this should be there, right? As a red one, or saying that it is not tracked. Now let's see git status. Right. You can see, of course, the git-igno file is there, but that text file is not there because text files are ignored. So don't worry, this is our git-igno file. Okay. Even you can include git-igno also in your thing. But if you change this to something else, because we only ask to ignore text files. If I change this to txt to see, say, XML, now it should be, your Git should not ignore it, right? Now if I type the same command, now it says readme XML is there. Because git ignore file says ignore txt files. Okay, so that is how you ignore certain files, okay? Ask your Git to ignore those files. Don't track those because those are my local things. Those are not supposed to go into the repository. Okay. Right. So then if you, at any time, if you want, you can just delete a file. Maybe now it's already, now let's add this particular XML file, readme.xml file. So git add readme.xml, and maybe I will commit also same time. Right. Ampersand, ampersand, and git commit, say minus m, say version 1 or something. And file name is again readme readme.xml. Right. So that means I do add and commit together. Right. Now if I type git status, okay, of course the git igno file is there, but that file is now added. Now assume that I want to delete that file. Okay. I want to delete that file. How to do that? Because you must know how to edit. When you modify, how to re-edit and commit, and also sometimes you want to delete it. No longer that file is needed. Not only from your local machine, from the repository as well, so that others will also not get that file anymore. Okay. Right. There are two ways. One thing is, right, you simply delete it from your local machine. Right. Local machine, you delete it. Then you commit it. So then that file will be deleted from the repository. So that is one approach. Okay. So the first approach is delete your file from File Explorer and check Git status. And it will find that, okay, it is deleted. Now let's delete this. First, you delete it from your local machine, okay? So I have deleted this. Now I will check the check status. Check Git status. So why is it not tracked? So it is not tracked as deleted, right? Why is that? That is strange. No changes added. Why is that? But I committed, right? So this one maybe the second part is not executed properly because I did both together using AND. Okay. Okay, so let's do it separately then. And so let's take a different file. Right, I'll call this hello. Okay. One.xml. One.xml. Let's add and commit separately. Okay. Right. Git status. Yes, one.xml. Git add. Let's do it separately. One.xml. Let's do git commit -m version 1 one.xml. Right now, if I type git status, now I committed. Okay, right, nothing. Now it has detected that the readme XML is deleted. You can see. I don't know. There was a small delay. Right. So remember we earlier deleted readme XML because now we have added the one XML. Now it says that okay, so your read that means earlier it has been committed. Okay. Now if I delete this one also, now it must detect that one.xml is also deleted. I think it takes a bit of time. Now let's type git status again. Now you can see both it has detected that one XML is deleted, readme XML is deleted. But remember, it's deleted in my local machine, but I have already added it to the repository, Git repository. Now we want to delete it from the repository also. Right? Delete it from the repository also. So how to do that? Just commit it. Just commit it. Okay. You can commit one by one, or you can say all the text files and so on. Okay. So let's commit one of those. So git commit I'll call -m, say cleanup. I will commit only one.xml. That means readme XML is not yet commit. Delete is committed. Okay, but I'm committing one.xml. One.xml. Right now it is deleted from repository also. Now if I type git status, now only readme XML is there. That means it says readme XML is deleted in your local copy, but it is available in the repository. So that means I have effectively deleted one.xml. Okay. So that is how you delete it. So that is one approach. There's another approach also where you can just say uh, git rm. So then both your local copy and the repository copy will be deleted. Okay. So then you make sure you commit it. Okay. Git rm and commit it. Now remember I have uh, okay, I deleted both. I deleted both. Okay. Because I deleted both. Right. So try this approach also. So then you don't need to physically delete it. So this command will delete it. And when you commit it, it's deleted from both local and repository. Okay. Right. So the next concept is branching. Branching. So branching means now remember we are in the main. Right. We are in something called master. Sometimes you can see that they say master somewhere. Say git log. And you can see you are in the head or master. That is by default, you are in the master or the head. But you can create this kind of branches. these kind of branches and work on that branch. That means you are doing some changes to the branch, not the master. That is called branching. So it's very easy to create branch. Just say git branch and branch name. That means you have created a new branch. Okay. So that will be your current head or the main is copied. Take a copy of that and consider it as a branch. So therefore now either you can work with after that, you can work with the branch or you can work with the head or the main. So some developers will be working on the head, some developers will be working on the branch. So those who are working on the branch are those who are working on that particular maybe customer's code base. So then you need to check out the branch, not the main, when you are working. So you need to be very sure about what you are doing. Otherwise, you are going to do a lot of disruptions to your project, right? Your team members are going to kill you, right? So that is why you need to know what you are doing, and you are a very disciplined, serious person, right? So let's create a branch. Say git branch. If I am getting this, I think there are some more. So how can I get rid of this? Should I type ESC or something? Q. Why can't I get rid of this? Okay, I'll take a different command line. Because this is giving me some issues. And so let me cd into that my git, okay? Cd this. Okay. Right. Git status. Right, that is fine. There's a readme XML file to be deleted. That is fine. Okay. Because I have deleted that. So let's commit that one also. Git commit -m cleanup or something. Readme.xml file. Readme.xml. Right now, if I type git status, right, everything is now sync. Okay, everything is now sync. Right now, let's create a branch. So how to create a branch? Git branch, your branch name. That means you are creating a copy of your main as a branch. Git branch. I'll call this customer one, the customer X branch. Right. So now we have created a branch. Now you need to check out if you want to work with that particular code base, you need to check out that branch. Okay, so how to do that? Because otherwise you continue working with the main or the head. Git checkout, and my branch name is customer X. Customer X. And so it says switch to branch customer X. Now you are in the customer X branch. Now if you type git status, so nothing to commit anyway. And also let's type git log. Right. So all the log is there. This is for the, now you can see you are in the customer X branch. customer X branch. Okay, customer X branch. Now, how can I get rid of this? Does anyone has idea how to get rid of this? Because I stuck with this end, but how to go to end? Right, colon Q. So usually in Linux it works. So I just tried out colon Q work. Okay. Right. So now I have created a branch and check out that branch. Check out that branch. Okay. So that is how you do it. And so again, if you want to check out the master or the main branch, maybe to a different folder, now just say git checkout master because now you have master and a particular branch. You can say I need to check out this branch or I need to check out the master. Then you can do merging. Say you do some changes to a branch, you can merge that file to the master, or from master you can merge it to a branch. Okay. So this is how you merge it. So git merge your branch name. So then your changes are merged to the branch, not to the head or the master. Okay. Right. So we all discussed about checkout. And either you can use checkout or there's another command called git switch. So when you switch to a branch, that is also same as checkout from the branch. Okay, so you can use any of those. And at any time you can delete a branch. So that means you want to delete that particular branch. You don't no longer need that code branch code base. Maybe you no longer support that customer. So then you can just simply say git branch minus the branch name. So then that particular branch will be deleted. Okay, right. So then tagging. So tagging is especially when you give a release, you give it a tagging, right? Release 1, release 2, release 3. So the advantage is now maybe you have given release 1, 2, 3. Later you want to get the code base that you gave as release 2. Now you are in release 5. So if you have done a tag before doing the release, you can check out that tag. So that means you check out the code base of that particular release or that particular tag. So that is the idea behind tagging. Tag is not a branch. Tag is taking a snapshot of your code base and give it a name. So that anytime you can get that particular snapshot of code. Okay. That is called tagging. Right. Don't worry about these lightweight tags and hard tags. So usually this is how you do the tag. Git tag minus say your tag name and the message. Right? Message is some descriptive instruction why you create this tag. Maybe you can say this is our version 1 to the customers. Maybe another tag release 2. That is called tagging. So tagging is simple concept. It's not like a branch because you can't merge to a tag. Tag is just a snapshot of the code and we have given it a name. Okay. But at any time you can take the code of that particular tag or that particular time point of time, the code base. Okay. And also you can see what are the tags available using the command git tag. Okay. Uh, you can check out the tag, right? You can check out the tag. So that means that particular snapshot, maybe you want to check out all the release 2 code base. Okay. Release 2 code base. Right. So that's it. That's it. So this covers everything in your UCSC note as well and little bit more about more also. But related to the JIT only, right? So then we have another one, right? Jenkins. Right. So this is 2022 question for A3A. Right? Question for A is third part's A part. Okay. You are working on a Git repository called BIT project that contains the following files. What are the files? Index HTML, style CSS, script.js. So those are three files in your local Git repository. Perform the following task by writing the appropriate Git command. Task 1. Initialize new Git repository called BIT project. So that is because you need to initialize. There is no Git repository. Now you are going to add these things as a new repository. So how to do that? We did that git init. Git init, and you can give it a name, your project name. So that is how we started also, right? Git init. Right. It's 3B. This part is the same. Add all the files in the repository to the staging area. Staging area means it's not committed, but you have added. So staging area means you add the contents. And commit the changes with the message initial commit. So first you add it and you commit. You can either do it as two steps or in single step using and then. Right? So you know how to do that, right? So if you give the file name, you need to add it separately because there are three files. So you just say git add, that means add everything. So both the answers should work. So either you just say git add, that means add all the new files, or you can say git add what are the files? Style.css, git add script.js, git add index.html. So then commit everything. So if you don't specify a file, that means everything. Right? Everything commit, everything add. Okay, everything add means everything not in your folder, but not in the repository. Right. C part. So this part is the same. Create a branch called feature and switch to the feature branch. Now you are supposed to create a branch and you are now focusing on that branch. So you want to check out that code from that branch. Of course, the same code, but now all your check-ins are going to, commits are going to get into the branch. So that is Git branch. Okay, Git branch, because it has told you that the branch name must be feature. Then make sure you check out that particular branch. Okay. So you create it and check out because you need to take that code base now. Otherwise, you will be having the main code base. So basically, your branch will have copy of the head. But after creating the branch, head will have, you can do further modification to the head, but those are not going to affect your branch. And independently, you can do changes to the branch. And also at any time, change that you have done to the branch can be merged to main. The change that you have done to the main, you can merge it to the branch or any other branch. Right. Right. So that is a past paper question. So, okay. So 2023, no past paper question from JIT. Okay. But 2022, there was a question. Therefore, in 2024, there's a higher chance that you get a JIT related question. Okay. Because last year there was no JIT question. Right. So that's it about JIT. JIT. Okay. Now we are going back to continuous delivery. Now this is continuous integration. And this continuous integration. So now we are going to the continuous delivery part. Right. So now we finished the last part. Now we are going back to the first part. Okay. Now that is right. Jenkins. Okay. Right. So we'll take 5 minutes break and then move on to the Jenkins. Okay. I'm not going to finish it, but I'm going to explain you the basics and how to set up it because setting up this particular Jenkins software is little bit serious. You need to follow your steps in a proper way. Okay, because it's a server. Right. So remember, Jenkins is a continuous delivery mechanism. So, this can take your code from the repository and build it, because repository is not going to do the building, right? Right. So I have prepared. It's actually, this note is partially prepared, but I will give you this version for the time being. Maybe tomorrow I can give you the full version. Okay. But tomorrow, because yeah, maybe for the time being, I will just put it into WhatsApp group. But this is not the final version. Git one, it's a final version, okay? But not this one. Let me take that. SQA. So this is not the final version, but we are running out of time, therefore we need to do it incrementally now, okay? I will upload the final version to the Google Classroom, right? Maybe tomorrow. Right. So what is Jenkins? It's an open source automation server. So it automates the build process. Right? Build, running the test cases, and deploy it to the servers. Of course, you know that how do you build our project? Maybe if it is Java, we can use and Maven, right? So then someone will ask, when you have build tools like Maven and, right, why do you need Jenkins or Jenkins? So just those tools are there, but developer need to build it by running, right click and run, or running some commands and so on. But Jenkins, what it can do is, it's like schedule job, right? It can take the code from the repository, build it, and run the test cases, deploy it, because after deploying only sometimes you can do some integration test and system test, automated tests like using Selenium and so on, right? So remember, Selenium you can test UI related things, but UI related things you can test only if your application is built and put it into the web server. So the deploy part. So all those things can be automated using tools like Jenkins. Okay. So basically take code from the repository, because earlier we talk about how working with the repository. Now it's take code from the repository, not from your local machines, and build, run the test, deploy, generating reports on the build status. Okay. And also we can write down different pipelines. That means different tasks, sequential manner, do this, do that, do this. So therefore, this is most sophisticated tool. Right. So what it does? So it pick the code from your repository like Git. You need to configure your Jenkins to your Git or whatever the code repository so that it can get it from there, and build, run the test, and generate the results and email it and give the results back to the developers, management, and so on. And build, test. Actually, before test, sometimes you need to deploy. These things are done by your Jenkins like servers or tools. Okay. So it's a different thing. but it needs to work with your repository. So you send your code to the repository, these tools take code from your repository. So this is continuous integration. So if this is all done and all success, you can even deliver it to the customer. So that is continuous delivery. So this is more related to continuous delivery. This is more related to continuous integration. Okay. Right. So the advantage is, so when you prepare these, set up these servers and manage your build scripts, automation scripts, your system engineers, cloud engineers, so they have less work to do because otherwise these repetitive, boring tasks they need to do each and every day. By the way, these are very boring things, right? So the interesting thing is software development, designing things, developing things, managing builds and so on. Now boring things. So boring things we want to get it done by tools as much as possible. And as humans, we want to do the more challenging, interesting things because boring things are boring, right? Right. So therefore, let these boring things that get it done by these tools. Right. So it can build your code base, run your unit test like TestNG test, Selenium test, of course, after deploying. And of course, it can integrate with Git, Docker, so that you can get the code from those repositories. Even Maven can be used as a build system. You can see all these things can be put together now. So therefore, it make it your faster development cycles, faster delivery cycles, because these things can be automated. Right? How to install and configure Jenkins? So the prerequisite is you must have Java. Okay, Java, and because you need to get code from somewhere, so we will be using Git. And Java is needed to run your Jenkins tool. Basically, it runs as a web server, and Git we need because we need to get code from somewhere. And of course, you need the admin privilege so that you can install the software. Okay. So I mean pretty much for the Windows environment. Okay. Right. How to install it? This is how you install it in Ubuntu. So you need to remember this because in the exams, examiner can ask how to install it in Ubuntu because usually these things are configured in Linux machines. Because build servers, web servers, database servers are Linux machines. So therefore, right, at least something like sudo apt install Jenkins. Okay. So these are setting up your repositories and so on. Right. Sudo apt update all your repositories and install your Jenkins. But we will do our practical in Windows machine. So on Windows, so the prerequisite is you need any of these versions. Actually, I tried to install with JDK 8 and I got errors. So then I had to change it to, I think, JDK 21, the latest JDK, and then I managed to run it. Okay. So therefore, when you install, if you get any error, read the error message. Right. Most frequent error is it may say that your current JDK does not supported by this particular Jenkins installation. And it will suggest what are the supported versions. So then make sure you download that particular JDK and set your path to that. That means path bin folder to that particular JDK. Okay, so that actually I also had to do that. Okay, so therefore there can be some issues. Make sure You can try with your current JDK, and if you get any error saying this version doesn't support, make sure you download because you can have multiple JDKs. Only thing is you need to change your path variable and bin folder. So therefore, not at all an issue to keep multiple JDKs. Of course, I have so many JDKs, right? Because enterprise application development for semester 4, I need a little bit older JDK. Others, we use the latest JDK. Right? So I have all the software in my laptop. SAMP is running. MySQL is running. Right. So just double check. Just try with your normal JDK. But if you get error, just read the error message and most of the time it will say your JDK is not supported. Very rarely that can happen, but it happened to me also. Right. Right. So this is how you download your. There are multiple ways. So this is the standard way mentioned in your UCSC note as well. So you go to the Jenkins website. Okay. Go to the Jenkins website. This is the way mentioned in your UCSC note. Okay. So you have the weekly releases and stable releases. So you can download the latest stable release. Right. You can see this is stable. Right. And you can say generic Java package var. So there are other options like you can install it as a Docker, Kubernetes, right? There's a separate Windows exe version, right? Fedora versions, Ubuntu versions. But let's download the WAR file and install because this is what your UCSC notes says. Just click on this, right? So then it will download a WAR file, .war file. It's a little bit huge file, right? I think it's about 500 megabyte file. Okay. So once it is downloaded, you can start doing your installation, assuming that you have the JDK installed. Okay. So I will cancel this download because I have already downloaded and installed also. Right. So it's about 100 megabyte file, not a very big file, 100 megabyte file. It's called jenkins.war file. Okay. So make sure that is your first option here. So just download it. Okay. So once you fully download it, now you can do the installation. Right now you can do the installation. So how to do that? Create a folder. Right, create a folder like in C4. Better to do it in C4, C drive, because sometimes you're in your D drive you don't have access. Okay, so therefore make sure you create a folder, say in C drive, called Jenkins, and copy that WAR file to that folder. Because I have already installed, I just explain it, right? Because you should be able to do it. Right? Say create a folder, say call Jenkins or something. I'm not going to install it because I have already installed it. I'll just explain, okay? Say you create a folder called say Jenkins or any name. Then copy that jar file. Copy that jar file. Uh, I already copied it. I have already actually downloaded and use it also. Right. So yeah, did I copied it? Let me double check. D Yeah, I copied it to codes BIT-25 sem6. Yeah, Jenkins. So just copy that. Okay, copy that. I will copy it to the C drive. I just created a folder called Jenkins. Where is that? And just copy it. Then take command line, cmd, go to that folder, say cd that. Now there you have the jar file. Okay, the jar file, jenkins.jar file. Where is it? Yeah, jenkins.jar file. You can see. Now you run this particular command. What is that command? So that is how you run your jar files. That is java minus jar jenkins.var. That is your downloaded file. Make sure that that file is in your folder where you have the command prompt. Okay, so just run it. So when you run it, you will get, let me delete, close my GitHub. And when you run it, you will get this kind of command line. Okay, this kind of command. You can see I have already installed it, java minus jar, right? Java minus jar jenkins var. Okay, and I got some error saying running with Java 20 is not fully supported, and it suggested me, anyway, it's not an issue, you just use this flag. Anyway, you may not get this error. So then I again run it, Java minus the Jenkins bar with this hyphen enable future Java. That of course I had to do it because I got that error message. You may not get that error message, okay? First of all, I got the error message saying that because I had 1.8 JDK, I got error message saying JDK 1.8 is not supported. Then I install pivot to my new Java, new JDK version. That means I take that bin folder, JDK bin folder to that my new JDK. Then it said it's too early, too new, right? So then it suggested me to run with this flag, and then I managed to start it. Right? I managed to start it. Okay. So, right. So you should be able to do it. And if you get error and if you cannot figure it out, just copy the or take a screenshot of the error and maybe put it into ChatGPT. ChatGPT also can tell you what to do. Okay. What to do. Right. So that is what you are supposed to do. Just run it. And if you get any errors, maybe you need to adjust your JDK or add some flags here. Maybe it will tell you, or maybe ChatGPT will tell you. Right. And once you don't have no errors, that means you ended up somewhere like here. Yeah, somewhere like here, like saying started. Right. So you can see uh, Winstone servlet engine running. Right. You can see. So when you get this kind of a message, that means your server is now running. Jenkins server is now running. Okay. So by default, your Jenkins server runs on 8080 port. If you want to change that 8080 port, if your 8080 is already used by something else, your UCSC note says what parameter to use so that you can start it in a different port as well. But in my case, I have not used 8080 right now, so therefore I managed to run it. Okay. And also, when it start up, it will show you the default password for the admin user. Right? Default password for the admin user. For example, yeah, this one you can see Jenkins install setup is required. Admin user has been created and password generated. Please use the following password to proceed to the installation. So just copy this password. And also the same password is available in this particular password file. Right? If you can't copy this, same thing, it's available in your, so it will give you the path because that is the initial password of the admin user. that you need to use to log into your Jenkins server. So once you get into this level, your server is up and running. Okay, server is up and running. Now you can access, of course, if you are using 8080, this particular URL. Right? So let me copy this. Let me copy this. That is after your server is running, okay? HTTP. Yeah. So it won't ask you to log in, right? It will ask you to log in, but the default username will be admin, but password will be empty. Now you know what to enter the password initially. So the initial password is what is mentioned here. Okay. What is mentioned here, just copy it, or you can get it from this particular file. Okay. So just enter your password. The default username will be already mentioned as admin. In my case, I have already changed my password. Then you just say sign in. You just say sign in. But when you sign in, you won't get this kind of a UI initially, right? Rather, you will get, this is when you are doing this first time, you will get, uh, so this I have explained everything. You will get this kind of a screen. That is when you just type this URL, right? First time. Then you will be asked to log in, and after login with this password, you will get this kind of a screen. Okay. And in this screen, just click on this install suggested plugins. Just click on this. When you click on this, it will start download and install set of plugins. Now you are in your web browser, okay? Set of plugins. It will, you can see, click and install basic plugins. It will take a bit of time, okay? You can see the progress. You can see the progress bar. For me, it took about 5 minutes because it download about 10 to 20 plugins, right, and install to the server. So once it is done, it will ask you to change the password in the next field. Right? Either you can skip it, or better you just change the password, because otherwise you need to remember, keep this password somewhere, this huge password. So in the next screen, after this is done, it will say, do you want to change your admin password? Make sure you change it. Otherwise, of course, if you don't change it, every time you log in, the username will be admin, password will be whatever the password mentioned here, which you need to keep. Or you can just create your password. In the next step, it will, in the next screen, which I have not given you the screenshot, it will ask you to change this password. Or at any time, you can change your password. I have already changed my password. Okay. So at any time, you can go to here, accounts, and change your password as well. Okay. You can change your password. Okay. So just change it to a simple password. Otherwise, you need to remember that big password. Right. So this is your dashboard. After those plugins are installed, you will get, look, when you log in, maybe you can change your password and again log in using the new password. You will get into this kind of a screen. But initially, there won't be any tasks. This will be blank. Right? So this is your dashboard. This is your dashboard. Okay. Is it clear? And if you face any error and if you can't proceed, just take a screenshot of that and clearly mention the error message and first ask for ChatGPT. And still, if it is not going to work, just send me a message, right? Screenshot. I can also help you. Right? It's not very difficult thing, right? Usually, that you need to double check whether sometimes you may get that error saying JDK is not compatible. That is a common issue, okay? Which has a very simple fix. Just install the correct JDK. Right. So now you will get this kind of a screen. So this is called the Jenkins dashboard. So there you can have scheduled tasks, right? Scheduled tasks related to build, integration, deployment, and so on. Okay. So that is how you install it. So once you get into this screen without any issue and just check whether you are getting any error messages here, right? So then you are done. You are done means your installation is now ready, right? Or continuously to give you logins and see whether there are any errors. Okay, right. So then you can create a small, of course, now you can create tasks, simple tasks, pipeline tasks, okay, and so on. So how to create a task? So I'll just show you how to create a very basic task because I have not finished preparing this note yet. I want to prepare the note and do the second half of this topic. That is how to create pipelines. Uh, I will show you how to create a simple task so that you can install and get familiar with this. Okay, by next class. So go to the new item, right? Go to the new item. So this is already I have created. Let me delete this item so that. Uh, okay, let me delete this item and delete project. Right now I don't have any tasks. You can see this is the sort of the screen you get. Okay, welcome to Jenkins. So then you can see there's something called create job, set up agents, configure cloud, right? So go to the new items. Go to new items. This is now you have changed your password and your installation is done, right? That means your service. Now this is your basically you're accessing the web server, right? It's when you run that war file, it install a local Java-based web server, right? Web server. Okay. Right. So now you go to the new items. Just give it a name. I'll call it task one. And here you need to select either pipeline or freestyle project. So pipeline we'll discuss next class because that is a little bit big topic. So today we are going to create a very simple task, which is not a pipeline task. Okay. Freestyle project. Classic general purpose job type that checks out from SCM execute build steps serially followed by post build steps like archiving and blah blah blah. So this is a simple task. This is not a very versatile task. So we'll do that kind of a task today. And you can see pipelining, multi-configuration project, and so on. But we will create a freestyle project. Just select this and then OK. Now only OK is enabled because you need to select one of those. Select this. OK. My name is task one. Okay. So what we are going to do is a very simple schedule job, like a DOS command, right? And there you go down, you can give a description, but it's optional. So there are some tasks related to JIT and so on. Let's not go into that. So just go to the build steps because we are going to do a very simple task. Build steps is way down. Now I'm in my first task, task one. You can see task one configuration. Go to the build steps and in the drop down, select execute Windows batch command. So that is the simplest possible, like a hello world task that we can do. Okay. You can see Ant is there. Remember, Ant is one of the Java build tool. Maven is there. Right? So that means you can integrate with your build. But we are going to do very simple Windows batch command because this is like a hello world. Just select it. And now you can type your command here. So you can type whatever the commands you want. Okay. So we will type these three those commands and see whether it is getting executed by Jenkins. Okay, of course, we can execute these things in command line also, but what we are going to do is automate it. Maybe this is a repetitive task. We can even schedule saying that, okay, run this task every day, 12 midnight. Okay, right. So I have given all the things in the note. Okay, all the steps. Right, build task, create a Windows task. Okay, right. Now what we are going to do is we are going to add a small. Uh, these are those commands. Okay, those commands. So we are going to create a temporary folder and run dir command and get that output to a text file. Of course, this is not a serious thing. I told you this is like a hello world application. Okay, hello world Jenkins. Right. So I have created a folder here. Uh, uh, Better to work with C folder because C drive has you have the full access. Right. I have just created a folder called Jenkins temp or any folder, okay, any folder in my C drive. So I'm going to CD in my batch doc in my Jenkins task. I'm going to CD into this particular folder. Okay, so that is my first task. Right? Where is my folder? Right. So CD into that. CD into this per folder. C Jenkins temp. Now that folder is empty. Like nothing is there. Okay, nothing is there. Now my second DOS command is I am going to create a folder called temp under this because now already we have asked you to cd into this folder. Okay, let's call it temp or whatever. Right? mkdir dir. I'll call it okay. I'll call it test. Just we want to see whether this is getting executed, right? That's all. Now I am going to run dir command that is list the directory, but we are going to put it into a text file, the result, so that we can physically see whether the command is executed. So that is very easy, right? dir, but I want to put the result into, let's say, out.txt file. So that means execute this command, those command, and you know that dir is a command, right? Normal command. So if you take command prompt, so dir will give you the files in the files and folders in the current folder. Okay, same command. But let's put it rather because you don't have command line. This is a tool. Let's put the output to the new file called out.txt. Okay, out.txt or any name. Okay, right. This is my Jenkins schedule task or the task. It's a DOS command task. Okay, it's a Windows batch command task because I use only DOS commands. Okay, I use only DOS command. Okay, now we are done. We can save it. We can save it. You don't need to go to advanced or whatever. If there's a post build steps, you can do that. That is after this is done. If there's anything else to do, okay? Right, test cases. Right now you can say save. Now you can see that in your dashboard, there's one task for task one. Likewise, you can create any amount of tasks. Right. So this is my task. Still, I have not executed this task. So this is to execute. Okay. Or you can schedule it so that execute this at this particular day, this particular time, or every week, this particular, or every day, this particular time, and so on. Okay, right. So let's run it manually rather than scheduling. Now remember, it's supposed to create a folder under this, and create a file list in the content of the directory under temp. So it's supposed to create a new folder called test and also file called out.txt. Now still it is empty. Okay. Now let's run and see whether it after getting executed, are we going to get this? Okay. Right. How to run it? You can see schedule a build for tasks. So I just say run. Okay. Run. Still it has been not run. It's just the task is created. Now it will be run. Now it says build schedule. Build schedule. Okay. Now let's see whether it has been executed. Now you can see that the test folder has been created and also output.txt has been created. That's 9:37 p.m. So that means it has been executed. And in out.txt file, uh, remember it is supposed to give me the directory dir command results of this. Yes. So it says you have out.txt, right? So this is your folder. So now it has been executed. Right? You can write any DOS command because it's a DOS type task. Okay, DOS. At any time you can run it again and again also, and also we can schedule it also. Right? And also you can see the build history for this particular task. You can see this is only last schedule build, how long it took it, right? How long ago, and also you can see you can take one of the thing and see the console output. So this is the console output of that particular task. You can see the mkdir. These things have been executed and it says success. Okay, right. So the next class, we will create some more tasks like new item, but we will create this pipeline task also. Okay, right. So therefore now so today also we are not going to do e-business because e-business we can do in the next class. But now, anyway, now we are done with network security and audit. Software quality assurance. Now we have done this almost, but 90%. This is 90% done. Only but we have one more topic because we are doing with past papers also. There's nothing called past paper discussions because we have done past paper discussion for these all each and every topic. So we need to do the mobile test automation that we will do after this topic is done. Right? So then this subject is also over. And definitely in one class, we can do 3 years of papers because the syllabus is over. Maybe next Wednesday, we can finish this. We can finish this. And Thursday, we can finish the rest of this stuff. Or Thursday, we can finish this and then come back to this. Okay. Right. So that is because we have done past papers also to these tasks. All these topics we have done topic plus past papers. Okay. So here just we have two more topics. Here we have just two more topics. Okay. Right. So definitely we can finish your syllabus. Right. I will be adding maybe next week also. You will be having 2 sessions, and possibly I try to add 3 sessions so that next week we are pretty much done with 4 subjects. Okay. Right. We stop at this point. Thank you.